In this video, we are going to talk about straight line, and we're also going to see different equations of a straight line. That means the different standard forms of a straight line. Okay. First, let's understand slope. Straight line has a unique property known as slope, and we calculate by taking any 2 points. Let's say this is A and this is B. For this part, for AB, slope will be calculated as rise divided by run. Slope is given by rise divided by run. In this case, slope of AB would be BC, right, divided by AC. Now, we want to see that the slope of a straight line is fixed. That is, if you take any 2 points, say here's another point C and here's another point D, you can calculate slope of CD. It will be equal to slope of AB. We are going to show that. Okay. First, let's find its rise and run. So let's call it E, let's call it F. Now for this, slope of ED is equal to DF, right? Here, this is rise, this is run. DF divided by PF. Now we want to show these two values are equal. Now we can see these two angles are equal because these two lines are parallel, and this is right angle, and the remaining angle is also equal. So we can say triangle ABC is similar to triangle DEF. And we know the property of similar triangles, the corresponding sides are proportional. So from this we can find BC divided by AC. BC divided by AC corresponding. Now the side corresponding to BC here is DF. And the side corresponding to AC is EF. So these two values are equal because of similarity of triangles. You can see here, this is equal to slope of AB, this is equal to slope of ED. That's why these two values are equal. This means for a straight line, the value of slope is fixed. That is, you can take any 2 points and calculate the slope, it will come out to be same. That means if you calculate slope between B and E, it will be still equal to these two values. Or you might calculate slope from A to D. It will still be equal to these two values. So they are same. We have to understand this. A straight line, for a straight line, the value of slope is fixed. And you can take any 2 points to calculate the value of slope. In this section, we are going to see how we calculate slope for 2 points. That is, when 2 points are given, how do we calculate slope? Let's consider this to be our axis. Let's say we have 2 points. Say this is x1, y1. Okay. This is another point, x2, y2. Now we want to calculate slope of these 2 points. Look for these 2 points. Okay. Now we can see that since this point is x1, y1, this value is nothing but x1, and this value is y1, right? Similarly, if we draw a perpendicular from here, this is our x2 value, and this is our y2. Now we calculate slope by using rise divided by run. We know this is our run, and this part here is our rise. Let's look at this. Now, how do we calculate this part when we know these two? You can see we can find it by subtracting x1 from x2. So we subtract this part from this whole, and we get this. That is our run, which is equal to x2 minus x1. Similarly, if we want to find this part, this will be equal to y2 minus y1. Subtracting this part from the whole part. The whole part is y2 and this part is nothing but y1, right? So we can calculate slope by using this formula. These are rise divided by run. Now, the order of these 2 points wouldn't matter because y1 minus y2 divided by x1 minus x2. These two are equivalent because when you multiply by minus on both sides, on both parts, both on the numerator and denominator. Okay, what do we get? We get minus y2 plus y1 divided by minus x2 plus x1, which is nothing but equal to this. So the order of the points wouldn't matter. The slope is given by y2 minus y1 divided by x2 minus x1, or subtracting y parts and dividing by subtracting x parts. This is how we calculate slope when we know 2 points. In this section, we are going to see what general equation of a straight line is. Now, how is a straight line even related to an equation? Okay. Let's consider these to be our axis. These are x-axis and these are y-axis. Now, let's say we have a straight line. Okay. Now, how can it be represented by equation? We say ax plus by plus c equals 0. This is our general equation of a straight line. That means any equation in this form will always represent a straight line. So, if this is a straight line, this also has some equation of this form. Okay, let's consider these equations. Okay, these two have same form, so it also represents a straight line. Now, this also represents a straight line. Now, this will not represent a straight line because we have a square term here. So, for an equation to represent a straight line, it should have only the linear terms. That means the maximum power of the variables should be 1, or the maximum degree of the term should be 1 only. Only then it will represent a straight line. So, what does it mean for this equation to represent a straight line? That means if this equation is plotted, or the xy values that satisfy this equation are plotted on a graph, that will result in a straight line. So, an equation represents a straight line means we are plotting the xy values on the graph and that will result in a straight line. For example, let's take this equation. Okay. 3x plus 4y minus 12 equals to 0. Yeah. Now, let's put x equals 0. We get y equals 3. So, 0, 3. These are one pair of values that satisfy this equation. Let's take another by putting y equals 0. So, you can put any number here, but it's easy when you put 0, right? So, we get x equals 4. So, x is 4, y is 0. This is another pair of values that satisfy this equation. So, if we plot this on our axis, 0, 3 means 0, 3. Let's say these are 3 and this is 4, 0. You can take as many numbers as you like. You can find infinite number of pairs that satisfy this equation. To construct a straight line, we only need 2 values. So, I am taking only 2 values. So, if you plot this, you would get a straight line. So, this equation represents this straight line. This is straight line. That means any point that lies on this line satisfies this equation. That is, we have specific xy value for this point, another for this point, another for this point. These all pairs will satisfy this equation. That is the main idea of equation. Okay. Now we'll see different standard forms of the equation. Now we'll see how do we calculate equation of a straight line when 2 points are known. The 2-point form means when 2 points are known. Let's consider these 2 points, A12 and B45. We want to calculate the equation of line that passes through these 2 points. Now, in earlier section, we talked about a unique property for straight lines known as slope. That is, for a straight line, the value of slope is fixed, in which we can take any 2 points to calculate the value of slope, and that will be equal. It means, let's consider a point here. If we calculate slope of CA and slope of AB, it will be equal. Let's take another point here, D. If we calculate slope of DA and slope of AB, it will still be equal. So any point on this line would satisfy this. Right? Slope of CA would be equal to slope of AB. So now what we're going to do is consider this C to be our arbitrary point. Let's consider our C to be here. Okay, it could be anywhere. For convenience, I'm taking it to be here. Now we calculate slope of CA or AC. It is the same thing. We just saw that. How do we calculate it? We calculate by subtracting the y parts. It is y minus 2 dividing by x part. Again, for AB, we will subtract the y parts, 5 minus 2, and then subtract the x parts on the denominator. Now, y minus 2 equals, this is 3, this is x minus 1, this is 3. Now, 3 times 1 is 3, so it will be equal to y minus 2 equals to x minus 1. When you take everything on the other side, it will be x minus y plus 1 equals to 0. So, this is the equation of this line, because every xy value will satisfy this thing here. So, any point on this line will satisfy this equation. So, this equation represents this line. Now, let's consider this to be our x1, this to be our y1, this to be our x2, this to be our y2. Now, we are going to find the general idea behind finding equation of line. Okay, what we did was subtracted y parts, y minus y1, and subtracted the x parts. This slope of AC, and then we equated it with the slope of AB, which is given by now y2 minus y1 divided by x2 minus x1. This is the main idea here in 2-point form. We always use this equation to find the equation of a straight line when 2 points are known. Or it could be simplified by writing y minus y1 is equal to y2 minus y1 divided by x2 minus x1, and then x minus x1. Now, there's another form which is similar to this one, which is known as the point slope form. That is, when we know a point, passing point, and the slope of the line, we can calculate the equation by this similar form. Here, y2 minus divided by x2 minus x1 is nothing but slope of the line. Now, we represent slope by m. Okay, this is our general notation. So, we write m. So, these two forms are equivalent. And we apply this when we know the slope and the point. And we apply this when we know 2 points. Okay. Next section, we'll see another standard form. Now, we are going to look at slope-intercept form. Here, intercept refers to where the line cuts the axis. And in this, we are talking about y-axis. Okay, slope, y-intercept form. That is, we know the slope of the line. Let's say this. Okay, we know slope of this line, right? And also we know this part. This is our y-intercept. That is where the line cuts the y-axis. This is C. So the coordinate of this point will be, since this is origin, this is 0, C. So this is 0, C. Now, we'll apply the similar rule for a line, that is, slope is fixed. Okay, so slope of, now we consider any arbitrary point. Slope of this point, let's call it A and let's call it B. Slope of AB is nothing but M, because we know the value of slope. Now, slope of AB is given by subtracting y parts and subtracting x parts. So it will be equal to y minus c equals, this is x. Sorry. So this is equal to y equals to mx plus c. So let's say we have been given, let's say slope is 2 and y-intercept is okay, y-intercept is 3. Then the equation of line would be y equals mx, means slope is 2x plus 3. So in this way you can find the equation of slope. Also, equation of line. Also, let's say we have been given a line, right? Let's say 3x plus 4y equals 12. Now, how can we find the line? How can we find the slope of the line and y-intercept? Well, we transform this into this form, and then we separate y. We take everything to the other side. No, 3x will be minus 3x plus 12, and we divide by 4, so it becomes minus 3 by 4x and 12 by 4. This is 3. So if we compare these two, what do we get? We get m equals minus 3 by 4 and y-intercept is nothing but 3. So in this way you can find the slope of the line when the equation is given. Let's make a general formula. From the general formula, let's say we have been given equation in this form. What we do? We separate y, so it becomes divided by b. And we compare, so slope is given by minus a by b and y-intercept is minus c by b. Here, this is minus a by b. It is minus coefficient of x. A is nothing but coefficient of x and y is, b is coefficient of y. So, slope can be calculated by this form when general equation is given. Right. Similarly, here, if we apply this formula, it would be, slope would be minus 3 by 4. This was what we calculated. Right. So, in this way, you can find the slope of line. Next, we'll see another standard form, which is intercept form. In this section, we are going to talk about intercept form. That means we know both the intercepts. Okay, let's consider these are axes x, y. We have a straight line like this, and we know the intercept. Let's say x-intercept is a and y-intercept is b. So the coordinate of this point would be a comma 0. And this would be nothing but 0 comma b. Again, let's call it a and let's call it b. You take any arbitrary point x, y to find the equation. We use slope of, we can take anything, cb or ca, it doesn't matter. Okay, slope of ca will be equal to slope of BA or AB. Okay. The slope of CA would be calculated as subtracting y part, y minus 0 and x minus a. Slope of BA will be subtracting y parts, b minus 0, subtracting x parts, 0 minus a. This is y. This is nothing but b divided by minus a. This is x minus a. Now we cross multiply to get minus ay equals bx minus ab. Now we separate x and y to one place, so it becomes bx plus ay, and here we have ab equals. Now if we divide by ab on both sides, here ab will cancel out, it will turn out to be 1. Here b will cancel out, x by a, it would be y divided by b. So this is our standard form in intercept form. If I give, let's say the question says your intercept is 2, y-intercept is 3. What would be the equation? The equation would be x by x-intercept plus y divided by y-intercept equals 1. That is x divided by 2 plus y divided by 3 equals 1. Now we can cross multiply. It will be 3x plus 2y equals 6. Right. In this way, you can find the equation of a straight line when intercepts are given. Or maybe if the question asks us to find the intercept, what we can do? Let's consider this equation. 3x plus 4y equals 12. Now if we want to find the x and y intercepts, one way to do it is reduce into this form. How can we do it? Just by dividing by 12 on both sides. By 12. So it will turn out to be 1. This is 4 and this is 3. So x by 4 plus y by 3 equals 1. So you can say x intercept is 4 and y intercept is 3 for this line. Right. There's another way you can calculate the x intercept. Right. If you want to find the x intercept, put y equals 0 and solve. Solve for x. If you want to find y-intercept, put x equals to 0 and solve for y. Okay. I think this will be easier than reducing into intercept form. Okay. For example, for this, if you want to find the x-intercept, what would you do? You would put y equals 0. So this is 0, and you divide 12 by 3, it becomes 4. And these are same thing. Again, if you want to find y-intercept, you put x equals to 0. Here, so it becomes 0 plus 4y equals 12. So y equals 3. That's it. These are y-intercept. These are x-intercept. Okay. I think this method would be easier. In this section, we are going to talk about perpendicular form, which is also known as normal form. The main idea here is to represent the equation of line in terms of the perpendicular. Now, where is that perpendicular? We draw it from origin to that line. Okay. So we represent this line, equation of this line in terms of this perpendicular. Now let's call this P. P is the length of the perpendicular, and let's call this angle alpha. This is x-axis, this is y-axis. So now we'll find these 2 points, the x-intercepts and y-intercepts, and we know the equation of line is given by this in intercept form. So in this right angle triangle, and let's call it A, B, and C. So in triangle OAB, we can apply cos alpha. Cos alpha will be, these are base OA and these are hypotenuse. These are OB. Now since we need to find OB, we'll write OB equals OA divided by cos alpha. Now OA is length of perpendicular, which is P. So OA is P by cos alpha. OB is P by cos alpha. This is P by cos alpha, which are x-intercept. Right. Similarly, since this is alpha, this is 90 minus alpha. This is 90 minus alpha. Since this is 90, this will be alpha. So if in triangle OAC, we can apply sin alpha. Sin alpha will be OA divided by OC. Since we need to find OC, OC will be OA divided by sin alpha. Again, OA is P, so OC will be P by sin alpha. So our y-intercept is P divided by sin alpha. This is our y-intercept. Now we find the equation by substituting x-intercept in y-intercept. Y divided by P by sin alpha equals 1. So this comes out to be x cos alpha by P plus y sin alpha by P equals 1. And ultimately, Tx cos alpha plus y sin alpha equals to P. So these are perpendicular form. Where is it useful? It is useful to find the perpendicular length. Now, let's consider this equation. How do we transform this equation into this form? We simply take coefficients of x and y. Okay, this is 3 and 4. We apply Pythagorean theorem. We find hypotenuse, considering this to be our P and B. So it will be 9 plus 16 root 25, which is 5. Now we divide both sides by 5. So it will be this will be our perpendicular length drawn from origin to the line. This will be our cos alpha. This will be our sin alpha. Now, let's say what would be the case if we had negative sign here. Now again we take 2 square and 3 square and take root. This is 4, this is 9, this is root 13. Now see, if this is negative, perpendicular length can never be negative. So we take negative root 13. Okay, we have plus minus, consider it to be plus minus. Okay, we take its sign such that this value will be positive. Here we took plus 5. Now here we will take minus root 13. So it will be divided by minus root 13x plus 3 by minus root 13 y equals minus 2 by minus root 13. So that it will be positive. So this will be the perpendicular length of drawn from origin to that line, represented by this equation. Okay, these are perpendicular form. If you want to find alpha, then let's, for this we said cos alpha is equal to 3 by 5. So alpha will be cos inverse 3 by 5. Or it will be also equal to, this is y sin alpha. This is sin inverse 4 by 5. These both are right. These are perpendicular form. Thank you. To summarize, we learned these things. We said for a straight line, we can take any 2 points to find the value of slope, because the value of slope is fixed for a line. So we can take any 2 points. This is the characteristic feature for a line. You have to understand this. And then you can calculate slope by using this formula. And the general form is given by this equation. And if we have equation in this form, we can calculate slope by using this formula, right? And we also looked at some standard forms that were 2-point form. That is to find the equation when 2 points are given, and slope point form to find the equation when slope and a point is given, and then slope-intercept form is to find equation when slope and intercept are given, and then intercept form. And at last, we also looked at perpendicular form, which was useful to find perpendicular length from origin to that line. Thank you.